Hello, so in this video, I'm going to give you some ideas on how to complete the problems, but it's not going to be an answer key. It's just going to give you some ideas on what to do. So let's try that. For the first problem on your homework for 8.1, what we have is the parallelogram property summary. Okay, so that's in the reading. So go back and look at that, what I submitted there. Give you, for instance, one of the properties is, use this for number one, both pairs of opposite sides are congruent. That could be your first one. Your second one could be both pairs of opposite sides are parallel. One pair of opposite sides are both congruent and parallel. That does make it a parallelogram. Another one's diagonals bisect each other, and let's see, both pairs of opposite angles are congruent. So those are the five, I believe, that were in the reading. So that could work. Okay, so now moving on to the sample problems that we chose for this chapter. This first one is about angles created in a parallelogram, and they have added this diagonal, which throws some other ideas in there. What I'm going to do is just break this down. Angle 3 right here, that one is opposite. That angle 3 is opposite this angle. Now, since it is a parallelogram, the property is those are congruent. So you know the measure of angle 3 right now is 122. Next, these, I'm going to highlight them, these sides are parallel. All right, we showed that with the arrow in the middle, not the slash is congruent. The arrow is what we want to mark the diagram with to show that they're parallel. Now, if you remember what I taught you in class, you want to look for the Z or the backward Z or the N. So, for instance, here's what I mean. You have right here a backwards Z. The inside corners, angles, so to speak, those are alternate interior angles. And when the lines are parallel, those are congruent. So you know angle 1 is 30 degrees. Okay, other concepts. This is a little more complex, so I'm going to create a similar problem for angle 2. Okay, so it's going to take a couple steps here. Now, one of the properties is consecutive angles are supplementary. So this angle right here is 58 degrees. Okay, these two angles will add up to 180 degrees. And because of that, all right, if we know that this entire angle is 58, right, and this angle down here is 30, we'll just take 58, take away 30, and this one must be 28 degrees. So that's how you'll solve that problem. All right, the second one is about the diagonals. Diagonals bisect each other in a parallelogram. Now, they did say it was a parallelogram. The diagonals bisect each other. That does not mean they have to be congruent, and that does not mean they're perpendicular. Oftentimes in our class, we have perpendicular and bisector combined. This is just bisect each other. All right, so what they're saying is P to N is 7. All right, that's all the way across. Since MO bisects it, right there's the middle. So these should be equal. P to A should equal A to N. So you can figure out what those are. A to O, all right, they told us A to O is 3. Since diagonals bisect each other, that should be the same as A to M. So use that information to solve number 2. Okay. Graphing the points, number 3. All right, so first thing you'll have to do is create your axis. Sorry about that, I don't have a straight edge. Use on a tablet. Okay, so -1, 2. I'll use different call it a negative 1, 2. Plot it real fast. 1, 8. And 5, 2. Okay, now this is a problem that can be a little bit tricky. All right. Now, the challenge with this problem is understanding that it's expected that we kind of go in an order. So if we go A to B, right, in this manner, it's in order. So then once we drop down to C, I've had students try to put D kind of in this area. That would put it out of order. The way they arrange the letters here, A to B to C to D, you're kind of expecting that is the orientation, or in this case, it's going to be, looks like clockwise. You can't go A to B, then D, and then back over to C. That's incorrect. So they kind of give the indication that there's multiple possible coordinates. Don't fall for that. D cannot be up here. It looks like it might be. That would be the mistake here. All right, so how do you find it? Well, D must be over here somewhere to keep that going. What I would do is simply count from B, 1, 2, 3, 4, 5, 6, over 2. So down 6, left 2. I would do the same thing from C. And that's where I would locate D. So that's it for number 3. I kind of gave it away, but that's all right. Tricky problem. All right, with this, a couple things I want to give you is beyond parallelogram, there's other figures. There's rhombus, rectangle. There's actually isosceles trapezoid. There's kite. So there's a few figures that we're studying, and I want to make sure that we show you what each of these represents. So if we have a parallelogram and they want to talk about the diagonals here, BE and CE being congruent is not necessary for a parallelogram. So what has to happen is BE should be the same as ED, and EC should be the same as AE. This is not necessary, though. Okay, so number 1 is not necessary. If we did have that, if BE was the same as EC, it could be a rectangle because a rectangle has to have congruent diagonals. Okay, so if that was the case, it would upgrade this to rectangle or square. BAE is this one, so let's get rid of these. Okay, B to A to E, this angle right here, is the same as C to D to E. Get the highlight too big. So they're saying this angle has to be the same as D to C to E, this angle. B to A to E is the same as D to C to E. That does have to happen. That's by alternate interior angles, so that's going to be the choice. All right, let's keep going through, even though we've got the answer. We need more information. AB congruent to BC. Okay, if that was the case, it would be a rhombus. So it would upgrade it to a rhombus because you have the sides the same. It's a parallelogram, and these are the same. It's a rhombus. Don't need it. This one's good. All right, DAE. This angle being the same as CBE. That's just not necessary. The only time that would happen is if it was a square, it would have to happen, but we don't need that. All right, so we've got the answer there. If you watch the video, you'll get the right answer. So about every parallelogram, all right, all 4 sides are congruent. That would make it a rhombus or a square. We don't have to have that for parallelogram. That's the idea, is it's not required. The interior angles are all congruent, not necessary. That would upgrade it to rectangular square. We don't need it. 2 pairs of opposite sides congruent. We need that. That's the correct answer. Diagonals perpendicular to each other. That's your kite or rhombus. Of course, square as well. So we don't have to have that. There's 1 through 5.